Welcome back everyone to the Hello World Guide. This is another episode of the C programming series. In this video we are going to finalize our makefile based build system. So in order to do that we are going to start off by creating the actual commands of our makefile. So what I'm going to do is I'm going to create a command called all, and we can run this, and this will basically build everything. So in order to do that, the way you do a command in makefile is you say the name, then you put a colon sign after that, and then here we need to put the command dependencies, all of the what needs to be modified for this command to run, and then we can also put the actual the actual what we want to execute when this command runs below it. So in order to do that, we are first of all going to say that the all will depend on essentially if the binary file, if we like create a different make changes to the binary files, then it should actually recompile the binary file if we make changes. So we are going to just, for the actual command, we are just going to say dot slash and then the binary file to run it. Most commonly we put the binary file inside the build directory, but I am actually going to put it in the root directory. Now we are going to actually define the rule for the binary file. So we will say binary file here, and for this I am going to say essentially all objects. With this means that if any of the object files, if you change any of the object files, then we will automatically have to recompile the actual binary file, because if any object file change, then we should recompile the binary file as well. And now for binary we just need to link it, and it is actually possible to use GCC directly as a linker. So we will say the C compiler, whatever we got, we will access the variable like that. To access variables we just use a dollar sign and parentheses, and here we will put this special symbol, which is this this symbol and followed by a dollar sign. Now what this means is that it will essentially take these objects, all of these objects that we have got, and it will put those objects in here. Now we are going to go ahead and say the O flag, so that we can actually specify the name of the output file, and we are going to use this. Now this sign will actually take this, so that it actually this is a special symbol. We are taking this value, which means it will take the binary file name, so that we create an executable of that name, and then we are going to pass the linker flags in the end. So this is for the actual linking. Now let's go ahead and implement the logic for actual individual file. But first let's use the include option followed by our dependencies to make sure that makefile knows that these are our dependencies for our include files, and if these changes, which means that if we change an include file, this will allow makefile to actually update based on include files. Without this, it will only change if we change a source file and not an include file, even though an include file does cause changes in the source file. So if we don't change a source file but change, for example, a constant value in the header file, it won't do that, but this will allow us to recompile it. So we'll with that, now we'll go ahead and implement each individual file. So we will say build dir slash, and then we will use %sign.o, which means all object files in there. So because we are storing our object files in the build directory, we have to do it that way, and then we won't actually put build directory here because our C files are in the root directory when we are specifying this here. So for the actual command we will just say cc for the GCC compiler or whatever compiler we are using, followed by the flags that we have got, and actually let's go ahead and change the flags a bit. We will add the mmd flag to actually generate the include dependencies, and the C flag as well. These flags will make sure that it generates an object file and not an executable, and it also generates the dependencies. So with that, then we put this symbol here, which means it will actually take this .c file, whatever C file we have got here, it will take that file, and then we will say O, and we will put this here, which we also used before, and this makes sure that it will tell it to output the file in build directory with the same name but the O extension. And that is pretty much it. That is pretty much all we need to do to actually go ahead and build the actual files. In order to actually test this, make sure you create the build directory in this folder, which is currently empty, but if I open up the terminal, and let me do that like that, and I am going to run the command. Now on Linux you can, if you have got makefile installed, you can just run make, but you can see make doesn't work. Now you can find a lot of make ports and softwares for Windows, and you can just go and search on Google. Personally I am using Minji W32 for 32-bit. You can also use the 64-bit version, and I will execute this command Minji W32 make, and there are a bunch of packages like Unix utilities which provide all Unix utilities capabilities in Windows. So if you're not on Linux or Unix, you can actually use those and download them. They should be pretty easy. Once you have any makefile software, should be able to run this. So we'll just run the makefile and it will automatically get this makefile that we have created, which is the reason that this name matters. So now let's go ahead and do that, and you can see it actually does that and then runs the file as well. And now we can go ahead and do whatever we want with it. And in the build file we have got functions.d, which you can see actually provides us with all of the dependencies here. This depends on functions.c and functions.h. main.d it depends on main.c, so main.o depends on the c file, and functions.h, so it does that, and it also creates the binary object files for us in this build directory, and it creates bank.exe as well. I have added another recipe or command or whatever you want to call this here, called clean, and this essentially deletes all of the files in our build so that we can actually go ahead and do that. So if I run this, you can see that it did not work, but the main reason it did that is because I am on Windows and I need to use a backslash here because it takes that as switches. So it asks us if I want to do it, and I can say yes, and it works. You can see that the build actually is deleted. So yeah, that's pretty awesome, and this is pretty much it for this video. In the next video we'll continue with the actual software part, and now that we have got a solid build system in place. So stay tuned for that. I will see you in the next one, and make sure to like and subscribe as well, and bye.